Hi everyone, welcome to the session 9 of System of Particles and Rotation Motion. So in this we are discussing about the concept of moment of inertia, correct? So already we have seen some specific objects and what are their moment of inertia values, and even we have talked about the two theorems. One is the parallel axis theorem and other is the perpendicular axis theorem. So today again we will start with some more shapes, and we'll talk about what is the moment of inertia of these shapes, and then we'll also try to solve some problems. So here we are not going to cover some of these derivations, because actually you look at it now, we're talking about the moment of inertia of a solid sphere. This is a solid one, this is the hollow one, hollow sphere. What is the difference? Solid sphere means the mass of the sphere is in the entire bulk or volume, so it is spread in that volume of 4 by 3 pi r cube. Hollow sphere means what? Mass is only on the outer surface. Hollow means what? Mass is only on the outer surface, which is our 4 pi r square area. Now of the solid sphere, because solid sphere mass is in the entire bulk or volume, which means mass is distributed starting from the axis, it is distributed. So look at the moment of inertia formula, 2 by 5 mr square. What about the hollow sphere? We cannot represent whether it is a hollow or a solid, that's why we are using the same diagram. Don't think that why we are not giving different diagrams for that. Why we are using same diagram? Because we cannot show what is there inside, right? So you see a hollow one, mass is only on the outer surface. Means what? Mass is distributed farther from the axis. That's why we will remember it. Remember the formula. So here the derivation we are not seeing it. We will make a separate video on the derivations of the moment of inertia of the hollow sphere and moment of inertia of the solid sphere. Both of these values are with respect to which axis? Diameter as the axis. So the solid sphere value of the moment of inertia will be less. Look at this, 2 by 5. Denominator is a bigger number, that is why it is less. Hollow sphere, what it is? 2 by 3. So generally people remember this, one is 2 by 5 mr square, other is 2 by 3 mr square, but suddenly we might get confused which is this, and for that what is the thumb rule? Solid means mass is starting from the axis, mass will be distributed. So mass is staying closer to the axis, right? So it will be what? Lesser. So denominator we should have a bigger number, that is what? 2 by 5 mr square. Okay. So the derivation how it comes we will see in a separate video. Look at this question. Find the moment of inertia of a solid sphere. We have a solid sphere, of mass m and radius r about the axis xx, which is shown in the figure. You know what this is? This is a tangent drawn to the sphere. It's a tangent drawn to the sphere. And also we have to find the radius of gyration about the given axis. So first of all, how do you find the moment of inertia with respect to the axis xx? Think about it. We can draw a line parallel to that and passing through the center of mass. That is what we will be calling as the center of mass axis. So what is the theorem we are going to use here? It is the parallel axis theorem, right? So we have to find the moment of inertia with respect to tangent. Just we will draw a axis parallel to that which is passing through the center of mass. By the way, what is this? This is also the diameter, right? If you draw a line through a sphere passing through the center, what is it? It is the diameter. What is the distance between the two parallel axes? The radius of the sphere. Now what is the parallel axis theorem concept? Parallel axis theorem can be used for any type of object, right? We have a limit only on the perpendicular axis theorem, because perpendicular axis theorem can be used only for the plane objects or 2D shape, laminas. Parallel one can be used for anything. So look at the formula, what is it? I is equal to ICM plus M into R square. What is this R? This is the distance between both the parallel axes. What is I center of mass? This is the moment of inertia of a solid sphere with respect to diameter. What is the value? Just now only we discussed it, right? What is it? 2 by 5. Solid is lesser, so 5 will come in the denominator. Plus mr square. What is it? If you take LCM means it will be what? 7 by 5 mr square. That is the moment of inertia about the axis xx. That is the tangent. The question is not over it, right? Check it, guys. What is the answer? It is what? 7 by 5 mr square. The question is not over it. They are also asking us to find what is the radius of gyration. So how do you find the radius of gyration? Remember, what is the concept? Whatever is the moment of inertia with respect to the given axis, we say it is what? Some m into k square. This k will be called as what? Radius of gyration. If you replace the entire object by a single mass, which is kept at the distance k from the axis, that k is going to be called as what? Radius of gyration. Correct? Now cancel mm. Take a square root. What you will get? Root 7 by 5 times r. That is our k. What is the radius of gyration, guys? It will be what? Root of 7 by 5 into k. Check it. Okay, so clear, guys? Now we'll go to one more question. Let's see. Two rings of radius r and nr means, this is a ring of radius r. There is a ring of radius n times r. I mean, the way I'm drawing it is looking like n is a number more than 1. That's how I've drawn, because I've drawn a bigger ring, right? If you look at these options, right, they're finally asking us what is the value of n. One of the options they are saying n is half, means if that is the answer, means it will be a smaller ring. Okay, but just we have to draw differently. That's why I would write it like what? Bigger one. Two rings of radius r and n are made up of the same material. Have the ratio of moment of inertia about the axis passing through the center as what? 1:8. From there we have to calculate what is the value of n. They have not said what is the axis. There is an axis passing through center. So what we can do is we can take, because they have not said, right, for both of them let us take the principal axis. What is principal axis? We have a ring, axis passing through the center of the ring and perpendicular to the plane of the ring. For this first one, right, mass of the first into r square. Correct? Moment of inertia of a ring about the principal axis is what? Mass of the ring into r square. Second one, its mass. What is the radius of this? nr. So nr the square will come. Now how do we know? So in this, right, you can see it here. What is happening? m1 is 2. This is like what? n square r square, right? So r square is cancelled. So what is it? This is the ratio. This ratio they are saying it is what? 1:8. From this we have to find n value. From this we have to find the n value. So how do we get n value? Because we should know the m1 is to m2. Then only we will know the n. So how we can get the m1 is to m2? Look at the question statement again. Two rings of radius r and n are made up of the same material. See, ring is like what? Mass is only on that circumference or the boundary. Ring means what? Mass is only on the circumference of the boundary. Same material means they have the same linear mass density. So m1 I can say is what? Lambda into 2 pi r, because the length of that ring is what? Length of the ring means that perimeter is what? 2 pi r. m2 will be what? Lambda, because both are made of the same material. 2 pi into nr, because 2 pi into radius of that other ring is what? N times r. Now just put those values, right? What is it? Lambda into 2 pi r is 2. Lambda into 2 pi nr. Already there is a n square. So you see here, lambda gets cancelled, 2 pi gets cancelled, r gets cancelled. What is remaining? 1 is to, already there is a n square and one more n is coming. What is it? 1 is to n cube. What are you getting here? 1 is to n cube. So 1 is to n cube is equal to 1 by 8 means what? 2 cube. Take a cube root on both sides straight away. What is it? 1 by n is equal to 1 by 2 means what is the value of n? N is going to be 2. Check it, guys. What must be the answer we should get? Option A should come. What is the answer we should get here? It should be what? Option A. Okay. So this is how we can solve these problems. We'll go to one more question. Huh? Let's look at this one. This is also interesting. 3 identical thin rods, each length L, there is a separation here. Huh? Each length L and mass M are joined to form the letter H. How? Like this. 1, 2, 3. 3 rods. What is the moment of inertia of the system about one of the sides of H? Means sides are these, right? These are the sides, right? So we have to take the axis like this. This is how we have to take the axis. Look at the question, what they are saying. What is the moment of inertia system about one of the sides of the H? See here, we will go one by one. Moment of inertia of the first rod about the axis is 0. Why? Because the rod is fully on the axis. Correct. Moment of inertia of the second rod, look at this. The axis is like an axis passing through end of the rod and perpendicular to the length of the rod. What is the value for this? It will be equal to what? ml square by 3. Now we'll see something interesting. For the rod 3, look at rod 3. Rod 3, each and every part of the rod you take, it is at a distance L from the axis. It is at a constant distance. Remember, this is a point that we have seen before. If you have an object like typically rod, where each and every part of the rod is at a distance x from the axis. If the rod is having a mass m, then what is the moment of inertia of the rod about the axis? M into x square, right? Same thing here. What is it going to be? The moment of inertia of the third rod will be equal to what? M into, what is the distance? Here, what is the distance? L, right? So, M into L square. Now, we have to find what is the moment of inertia system, means what? The total. So, what is it? I1 plus I2 plus I3, right? So, moment of inertia system is what? 0 means we don't have to add it. ml square by 3 plus ml square. What is it? 4 ml square by 3 will come. Check it, guys. What is the answer? Option D should come. What is the answer we will be getting? It is what? Option D. Correct. Now, this is another interesting question. 4 particles, each mass m. There are 4 particles, each is having a mass m, lying symmetrically on the ring of the disk. There is a disk of mass capital M and radius r. Where they are lying symmetrically. Symmetrically means what? If you have the disk of mass m and radius r, symmetrically means what? Like you draw 2 perpendicular lines, 2 perpendicular diameters. They will be at the ends of the diameters. Like, you know, this is mass particle m, 4 particles. The moment of inertia of this system about an axis passing through one of the particle and perpendicular to the plane of the disk. So it should pass through one of the particles. The axis must pass through one of the particles. So let us call these particles like 1, 2, 3, 4. It is passing through one of the particles and perpendicular to the plane of the disk. Okay. So here the thing is we have to separately find out what is the moment of inertia of the disk about the axis and also what is the moment of inertia of the 4 particles. See, for particle 1 that is on the axis, moment of inertia will be what? 0. Particle 2 and particle 3. Look at this is a right angle triangle, right? R and R. So distance is what? Root 2R. Right angle triangle, hypotenuse. Particle 2 as well as particle 4, right? They are at how much distance from the axis? Root 2R. How the root 2R comes? Again, if you just draw it separately, right? It's like this. We have the right angle triangle. This side R, this side R. So this is the location of particle 4. This is where the axis is passing through. So what is this? This is like the hypotenuse. What is it? Square root of R square plus R square. What is it? Root 2R. That's how it comes. So I2 as well as I4 both are equal. What is the value? M into D square means what? M into root 2R the square. That is what? 2mR square. Both are equal. What about the third particle? Third particle is at a distance. What is the distance of the third particle? Look at this. I will just erase everything. What is the distance of the erase even the numbers. So we should not erase them, so that we'll. So this is the axis, right? What is the distance of the third particle from the axis? This is 2r. Because r and r2 are right. So I3 will be what? We should have small m, because small m is the mass of each particle. Small m into 2r the square. That is what? It is 4mr square. Okay, so first particle 0, second particle, fourth particle 2mr square each. Third particle is what? 4mr square. So total 4 particles, right? What is it? 0 plus 2mr square. That is second particle. Third particle is what? 4mr square. Fourth particle is what? 2mr square. Totally what is it? 2 plus 4 plus 2 is what? 8 small m r square. This is the moment of inertia of all the 8 particles. Because it is an MCQ type of examination, right? By now itself we can guess the answer, because only one of these options is having 8 mr square. Check which one? Option B, right? Look at this. If you open up this one, what is it? 3 capital M r square by 2 plus 16 into half is what? 8 small m r square. So only one of these options is having which one? That 8 mr square, 8 small m r square term, which means none of the others are having. So by this itself we can guess our answer. What is it? It should be option B. It's not like, randomly guessing it, because that is the only option which is having this 8 small m r. Other things are not having it. Other ones are not having this 8 small m r square. Correct? Now we look at the other. What is the other? You have the disk. Disk of mass m and radius r. We have to draw a tangent which is perpendicular to the plane. Means if you think about an axis which is parallel to this and passing through center of mass, that is our principal axis. What is this? This is the principal axis, right? Disk, tangent perpendicular to the disk plane. Draw a line parallel to this passing through center of mass. That is our principal axis. So what is the concept here? I is equal to ICM plus distance between the two axes, what? R. But what is ICM? Moment of inertia of a disk about the principal axis. What is it? mr square by 2. 3 capital M r square by 2. That is it. That is the moment of inertia of the disk. Now total moment of inertia means what? 3 capital M r square by 2 plus 8 small m r square. Now this is where if you take out the r square by 2 common, we have to see the way the options are given. What are we going to get? 3m plus 16 small m is going to come. So check the answer, guys. What is it? Option B. Anyway, even before doing the entire problem itself, we were able to conclude it a little bit, right? Okay, let us go to the next one. What is it? A wire of length L and mass small m is bent to form a rectangle ABCD. So we are bending that wire to form a rectangle ABCD in such a way that AB is to BC is equal to 2. The ratio of the adjacent sides is what? 2. The moment of inertia of the wire means wire frame is now formed. The moment of inertia of the wire frame about the side BC is how much? What they are asking? Moment of inertia of the wire frame about the side BC. So look at this. This is like the wire frame we created. What is the total length? L. For that, what is the mass? M. We said AB is to BC is in the ratio of 2. Means this is like, if we say this is 2x, BC is what? X. Rectangle opposite sides are what? Equal, right? So AD will be x and DC will be what? 2x. Add all these sides, what we are going to get? 2x plus x plus 2x plus x. What is it? 6x. 6x is equal to what? L, which means x is equal to what? L by 6. So what is this? 2 into L by 6 means L by 3. Here also L by 3. This is L by 6, this is L by 6. These are the lengths. These are the lengths. Now what about the masses? Because mass will be proportional to length, right? Mass will be proportional to length, which means what? Here the mass will be m by 6. Here it will be m by 3. Here it will be m by 3. Here it will be what? M by 6. So we are able to see what is the mass of each of these portions and also what is the length of these portions. It's a rectangular frame, but the way we visualize it is what? It is like 4 rods like that. This is like one rod, AB. BC is like another rod. Both are identical, by the way. Now the axis is what? Passing through the side BC. That axis is like both AB and DC, right? It is like what? Both of them are like rods with axis. How is the axis? Passing through end and perpendicular to the length. How is the BC axis? It is like, the axis passing through end and also perpendicular to the length. What is the moment of inertia formula? For each of them, because they are identical, right? So for each of them, it will be what? Mass of that portion of the rod, which is m by 3, into square of the length. Length is what? L by 3. That's why we have to square of the length, divide by 3. Remember, if you have a rod of mass m and length L, if you have an axis passing through end of the rod and perpendicular length, what is the moment of inertia value? M into L square by 3. For each of them, it is same, right? So we have to put a 2. We have to put what? 2. That is the moment of inertia of AB as well as the DC added. Okay, so we can simplify this. So here we can even simplify this. So how much we are going to get? Look at this. What is this? This is what? L square by 3 means, L by 3 whole square means what? It is L square by 9. So 2 into m by 3 into L square by 9, already there is a 3, which is what? 2ml square by 3 3s are out, 9 9 9s are 81. So 2ml square by 81. Let us keep it separate. This is what the moment of inertia of both the AB part and DC part added. This is the moment of inertia of both the AB part and DC part added. Okay, so what is this? Moment of inertia of the AB part plus moment of inertia of the DC part. Both are added to give us what? ml square by 81. Now what about the moment of inertia of the portion BC? That is 0, because that is fully, that rod is fully on the axis. That rod is fully lying on the axis, right? So it will be what? 0. For that it will be 0. Now what is the other part remaining? The moment of inertia of the portion AD. This AD is each and every part of distance. What is the fixed distance value? L. This is what? What is this distance? It will be what? L. Erase this and then show it again. So if you take any small element of the AD portion, This is at a fixed distance of what? L by 3 from the axis. So the moment of inertia of that, which is the portion AD, will be equal to what? Mass of that, which is what? AD portion, what is the mass? M by 6. M by 6 into the fixed distance, the square. What is it? L by 3, the square will come. So M into L square by 6 into 9. What is it? 9 6 are what? 54. So M L square by 54. So the portion AD is like a rod which is having each and every part of the rod a fixed distance from the axis BC. That's why we are using formula what? M x square formula. What is the formula we are using here? M into x square. M means the mass of the rod. X is the distance. Okay. So the mass of the rod is what here? In this particular problem, it is what? M by 6, mass of the rod. Distance x is what? L by 3. So this is the AD portion moment of inertia. Now they are asking what is the total moment of inertia of the wire frame. What is it? We have to add all of them. This is anyway 0. So 2 ml square by 81 plus ml square by 54. We have to add both of them. So add both of them, what we are going to get? 2 ml square by 81 plus ml square by 54. So here we will have to take an LCM. What is the LCM? If you see LCM, right, 81 2s are what? 162. 54 3s are 162. So we take the LCM of the denominator, means it is what? 162. So 81 2s, right? So it will be what? 2 into 2 ml square is what? 4 ml square plus here it is 3 ml square. Totally what is it? 7 ml square by 162. Check it. What is the answer we should get? Option B we should get 7 ml square by 162. So what is happening here? The wire frame, right, is divided into 4 parts. AB and DC identical. The axis is passing through end of the rod perpendicular to the length of the rod, that formula. BC portion is fully on the axis 0. AD portion is like a rod which is having each and every point which is at a fixed distance from the axis. This model of questions we have seen already quite. Next question, look at this. A uniform thin bar of mass 6m and length 12L. Like we have a bar. What is the length of this? 12L. What is the mass? 6m. Is bent to make a regular hexagon. A regular hexagon means what? We'll have 6 sides. Each side will be equal, which means what? Each of them is going to be 2L. Because what is the total length of the bar? It is a 12L, right? 6 equal parts we should divide, means what? Each of them will be having 2L length. And proportionally, what will be the mass of each of them? M. Because the total mass is what? 6m, right? Divided into 6 parts means each of these sides of the hexagon will have a mass m. Its moment of inertia about an axis passing through the center of mass and perpendicular to the plane of the hexagon. Like, center of mass means like, the center point of the hexagon. It should be what? Perpendicular to the plane of the hexagon. Now here, each side is identical or symmetric. Like, if you take a hexagon, from center one axis is passing perpendicular to the plane of the hexagon. Each side is what? Identical. What we will do is, we will try to find moment of inertia of one side. With respect to the axis that is chosen, we will try to find moment of inertia of one side. For that, what we will do is, this is the axis, right? This is the axis. There is a rod 1, like that we will say. For the rod 1, let us draw a axis which is parallel to the chosen axis and passing through the midpoint of the rod 1. Okay. We will use the parallel axis theorem concept here. So the I we want is equal to what? If this is what we call as ICM, right? ICM plus what is the mass of the rod 1? M. M into what is the distance between the two parallel axes R. ICM, we know what is ICM for a rod. What is the moment of inertia of an if you have a rod, right? There is an axis passing through the center of the rod, perpendicular to the length. What is the moment of inertia? Mass into length square of the rod divided by 12. Correct. So which means what? This is what mass of the rod is M. Length square. What is the length? Length is 2L. Divided by 12 will come. This R is what? The distance from the center, the perpendicular distance from the center of the hexagon to the side one. So how do you find the value of R? We have to use the properties of triangles. So here we have to use a bit of properties of triangles to find what is the value of R. In a regular hexagon, right, if you draw the center connecting to the vertices, the triangle that gets formed will be equilateral triangle. Okay, so this will be what? 60. Now the equilateral triangle means if you draw an altitude, that is also what? Median, which means total length of the rod one is what? 2L. So half the length means L. In the right angle triangle, right, what is tan 60 value? Opposite by base, which means from here if you rearrange means tan 60 is what? Root 3. So L root 3 is equal to R. What is the R value? L root 3. Okay, just we have to substitute it. Substitute and check what is the answer. So here it is what? 2L the whole square means 4L square. So first term is what? ML square by 3 plus what is the other one? The other portion is what? MR square. So M into what is the R value? L root 3, right? Square means what? L square into root 3 whole square means it will be what? 3. So check it, guys. This is what? The moment of inertia of the rod 1. All this we are discussing only for one rod. Finally what we are going to do? We have to do into 6. Why? Because there are 6 such identical sides are there. So look at this. What is it? Take an LCM. ML square plus 9ML square by 3. Totally what is it? 10ML square by 3. This is the moment of inertia of just one side. How many such sides are there? 6 identical are there. So total moment of inertia value is what? 6 times of 10ML square by 3. What is it? 3 ones are, 3 twos are. How much it should be, guys? 20ML square. Check it. What is the answer for this? Option A should come. So here all the 6 sides are identical, right? So we have taken one side, calculated what is the moment of inertia of the side with respect to the axis passing through the center of the hexagon and perpendicular to the plane of the hexagon. Then we simply did into 6 because there are 6 such identical sides. Now we will move on to the other type of shapes. If you have a angular disc means what? A disc which is having a inner cavity. The inner radius is R1, outer radius is R2. So which means 0 to R1 is the cavity. R1 to R2, this is where we have the mass. That is what we will call as the angular disc. Mass of this is also given. If you take the moment of inertia about the axis passing through the center and perpendicular to the plane, this is like our principal axis type. What is the moment of inertia formula? M into R1, M by 2 into R1 square plus R2 square. If it is a full disc, right? If it is a full disc means simply R1 will be equal to 0. Means there will be no cavity. Put R1 is 0 in this, what we will get? M into R2 square by 2. Remember that is the formula for the moment of inertia of the disc, right, about the principal axis. Mass of the disc into radius square by 2. So what is the formula for the annular disc? M by 2 into R1 square plus R2 square. Then we have a uniform solid cylinder. But see here, we have a cylinder of length L and the radius of that circular surface is what? R. Mass of the cylinder is M. Here the axis is an axis passing through the center point, and perpendicular to its own axis. Own axis means what? Generally for a cylinder, what is the own axis means? It is the principal axis. What is the principal axis? The line that goes through the center of the circular face and parallel to the length of the cylinder. That is the principal axis, right? So this axis that you're talking about is what? Axis passing through the center of the cylinder and perpendicular to its principal axis. It's what? Perpendicular to its axis means we're talking about perpendicular to its principal axis. So look at the formula. What is it? M into L square by 12 plus R square by 4. What is the value for this? It will be what? M into L square by 12 plus R square by 4. Look at this one. For a solid cylinder of mass m, length L and radius R, moment of inertia about the principal axis is equal to moment of inertia about an axis passing through its center and perpendicular to its principal axis. We have to get what is the relation between L and R. What are we supposed to get? We have to get what is the relation between L and R. L is the length. L is what? The length of the cylinder. R is the circular face radius. So this axis, right, which is passing through the center and perpendicular to the principal axis. What is this? Moment of inertia M into L square by 12 plus R square by 4. This is equal to moment of inertia about the principal axis is what? M R square by 2, correct? For a solid cylinder, what is the moment of inertia about the principal axis? M R square by 2. Equate both of them, M gets cancelled. So L square by 12 is equal to what? R square by 2 minus R square by 4. What is this? This is again R square by 4. So look at this, what we'll have. I'll write it separately here. L square by 12 is equal to R square by 4. 4 ones are 4 threes are. Means L square is equal to 3R square. That means L is equal to what? Root 3 times R. That is the relation between what? L and R. Next we have moment of inertia of a uniform solid cone about the axis joining the vertex of the cone with the center of the base. So base will be what? It will be a circular base. We can also call it as what? Right circular cone. A solid one. Solid cone with a base radius R. What is the moment of inertia? 3 by 10 mr square. What is it? The value is what? 3 by 10 mr square. Next we have moment of inertia of the equilateral triangular lamina. This is what? A 2D shape with a side A and mass m. For this, if you choose the axis passing through the center of mass, means what is it? It is the centroid and perpendicular to the plane. So how we should take the axis? It should be passing through the centroid or the center of mass and perpendicular to the plane. Like it should be perpendicular. If you look at it sideways, right, it will look like this, something like this. Okay, so this is the triangle, means the axis will be what? Passing through the centroid and perpendicular to the plane. Okay, this one is like you are seeing from the top. This is like side view. What is the moment of inertia? It will be what? M into A square by 6. Next we have moment of inertia of the cuboid. Okay, so these are also solid. Cuboid will take length L, breadth B and thickness T. Okay, so length is what? This side what is it? L. Breadth, thickness means like the height. If we take the axis passing through center of mass and parallel to side L, means what? Where is the side L? This is the right. So we have to take the axis as what here? This is the axis we are choosing. That is the axis. For that axis, right, what is the moment of inertia? M into B square plus T square by 12. You know how we will see this? Think of it. You have the cuboid like this, right? Just compress it as it is. Just compress it as it is. It will become like what? One sheet. It will become like one sheet. Okay, so with a breadth B and thickness 2 dimensions. We have the axis passing through the center and perpendicular to the plane. Further already we have seen a 2D sheet, right? What is it? It will be what? M into b square plus t square by 12. Similarly, if you look at the others, an axis passing through center of mass and parallel to side B. Where is side B? This is the side B. So the axis is what? This is the axis we are choosing. If you compress it, right? If you compress it, then the entire thing is going to become like a sheet. Length L and other dimension is what? T. Here also again, the axis is what? Axis passing through center and perpendicular. Like a rectangular sheet, axis passing through center and perpendicular to the plane. What is the formula? M into L square plus T square by 12. Just like that, if you take an axis passing through the center and parallel to side T, the axis must be what? Parallel to side T. Then that is our axis 2. In this case, what is this? This is the axis 2, right? This one. Okay. Think of it, if you just compress it, it is simply going to become like what? One sheet. Length and breadth. The axis is what? Passing through the center of the sheet and perpendicular to the plane of the sheet. What will be the formula? M into b square plus L square by 12. So whichever side the axis is parallel to, that side will not come in the formula. That's it. That's how easily you can remember it. What is it? M into b square plus L square by 12 when the axis is parallel to side T passing through center of mass. Vice versa. Okay, so this is about the moment of inertia of the cuboid. Then if you have a circular disc, we saw what is the moment of inertia about the principal axis mr square by 2. If you have an elliptical disc of semi-major axis, means from the symmetrical center point, the total length of the major axis we will generally take it as what? 2a. Semi-major axis is a and semi-minor axis is what? B. The length of the minor axis will be what? 2b. If you have the axis passing through the center of mass and perpendicular to the plane, what is the formula for that? M into a square plus b square by 4. If this is a circular disc, then what happens? A is going to be, which is equal to r, put this, m by 4 into r square plus r square will come. What is it? M by 4 into 2r square. That is what? mr square by 2. That is the formula for the moment of inertia of the disc with respect to principal axis, right? What is it? mr square by 2. Now the principle of superposition, right? We talked about it. In the initial discussion also we talked about what is the principle of superposition. What is it? If you have a object, we cut this in different parts, part 1, part 2, part 3, part 4. The moment of inertia of the total object will be equal to what? Part 1 moment of inertia, part 2 moment of inertia. We can simply add it like a scalar quantity. Okay, this concept is what we call as the principle of superposition, and the moment of inertia satisfies this principle of superposition. We will see one example on that. 4 holes of radius r are cut from a thin square plate of side 4r. That is a thin square plate of side 4r means what? It will be 2r, it will be 2r. 4 holes of radius r means diameter will be what? 2r, right? 4 holes are cut like this, symmetrically. The moment of inertia of the remaining portion about z-axis. What we have to find? The moment of inertia of the remaining portion about the z-axis. See how we will be able to do it. Z-axis means what? X and Y are in the plane, right? Z means what? Perpendicular to the plane. So 4 holes of radius r and cut from a thin square plate of side 4r and mass m. See, first of all, they are cut means some mass will be removed, right? So here we are dealing with the mass which is spread on a 2D surface. So we will first separately calculate what is the surface density. What is surface density value? Total mass is m divided by what is surface area? Side length of the square is 4r, right? So we have to divide this by what? 16r square. That is the area, total area. Because what is the area of the square plate? L square, right? L is the length of the side. That is 4r in this case. So it will be what? 4r the square means it will be what? 16r square. Okay. Now we have to go step by step. We have to find what is the moment of inertia of the remaining portion. As per the principle of superposition, right? Moment of inertia of the remaining portion is equal to moment of inertia of the overall, the original plate, minus, from that we have to subtract the moment of inertia of the cut parts, because the remaining portion will not be a symmetric part. The original sheet is symmetric. The 4 circular holes are also symmetric. So how do you find the remaining moment of inertia? Because superposition means what? The overall moment of inertia of the full plate initially. From that we have to subtract the moment of inertia of the cut portions. That will give us what? Moment of inertia of the remaining part. So first we will start with the moment of inertia of the original plate. For that we already have a result. What is it? A rectangular plate of edges A and B. If you have an axis passing through the center of the plate and perpendicular to the plane, what is the moment of inertia? M into A square plus B square by 12. We have seen this quite often in the previous results, right? So what is it? M into A square means what? This is 4r, B is also 4r. So 4r the square plus 4r the square divided by 12. What is it? M into 4r square means what? 16r square. So 16 plus 16 is what? 32. 4 3s are 4 8s are. So what is it? 8 mr square by 3. What is the moment of inertia of the original sheet from which we were cutting these portions? It is what? 8 mr square by 3. Now that is one of the reasons why I keep telling in some questions, right, as we are going through the solution itself, we might be able to kind of point out. So what could be the answer for this? Look at this now. Look at these options. In which of the options this 8 mr square by 3 is coming? Only in option C that is coming. Look at this. 8 by 3 mr square. From that we are subtracting some part. So here itself we can conclude, because in none of the others the 8 mr square by 3 is coming, right? So this is the moment of inertia of the full sheet which is original. From this we have to subtract the moment of inertia of the cut portions. From this we have to subtract the moment of inertia of the cut portions. Okay. Now we will just go look at what is the moment of inertia of the cut portions. So see, first we will take one of these circular holes. The axis is what? It is a tangent which is in the plane of the hole. It's a tangent which is in the plane of the hole. Okay. We'll just look at one hole. If the mass of this hole is a small m like that, we don't know what is that. We can find the small m value by using what? The surface density concept. We'll try to find it. If the mass of this is small m, radius is what? R. Moment of inertia about the tangent which is in the plane of the, this hole is created by having a disc, right? By removing a disc, right? So if you have a tangent which is in the plane of the disc, what is the moment of inertia formula? It will be what? 5 mr square by 4. This is the result that we already saw. Okay, so what is it? The moment of inertia. This comes from where? Parallax theorem. Moment of inertia of the disc about the tangent which is in the plane. About the tangent which is in the plane, what is the moment of inertia value? 5 by 4 mr square. How this comes, you can check. We have to use the parallax theorem. Okay. Now there are 4 such identical discs, right? 1, 2, 3, 4. All of them are identical with respect to x-axis. Means with respect to x-axis means what will be the moment of inertia? 4 times you have to do. That is what? All identical, right? So into 4 will come. With respect to y-axis, look at this. Y-axis also, the 4 circular holes or these discs that are removed, they are identical, right? Which means if you call this as Ix, that is 5 mr square. What about Iy? That is also same, right? It will be what? 5 mr square. Now as per the perpendicular axis theorem, right? If you take a z-axis, Iz will be equal to what? Ix plus Iy, which is 5 mr square plus 5 mr square, which is 10 small mr square. Remember, this is what? Not capital M, this is what? Small m. This is what? The small m, the mass of each of these removed discs. Now we will come to the final step. What is the mass of this removed disc part? What is the mass of the removed circular disc part? How do we tell it? The surface area. What is surface area? Pi. So we are getting the small m value. Surface area is what? Pi r square. For any circular hole that you take, pi r square is surface area. Into what is surface density? M by 16 r square. So look at this. M pi by 16. Small m is what? Capital M, pi by 16. That's it, just substitute. So what is it? 10. In place of small m, what we will get? Capital M pi by 16 into r square. This is the moment of inertia of the 4 circular holes which are removed now. So what is the moment of inertia for the remaining portion? The original moment of inertia 8 mr square by 3 minus, we have to subtract the moment of inertia of these cut holes. What is the moment of inertia of the cut holes? 10 m pi r square by 16. So in this, if you take mr square common, right? Mr square take common out, what is remaining? What is the remaining part? 8 by 3 minus 10 pi by 16 into mr square. That is our option C. We already have it. What is the answer? 8 by 3 minus 10 pi by 16 into mr square. So understand the concept here. We have the full plate. Moment of inertia with respect to axis passing through the center of that plate and perpendicular to the plane. That value we already have from the rectangular laminar results. Here we have created 4 circular holes. If you calculate what is the moment of inertia of the 4 circular holes with respect to the z-axis, there we had like 2-3 steps. Because they are removed now, the moment of inertia of the remaining portion is what? The original sheet moment of inertia minus the moment of inertia of the cut portions. Okay, so these are the kind of questions we need to be prepared for the applications of the principle of superposition. Okay, so we will see in the next class.